Okay, so this is part 2 of my last day of reviewing for the final. So again, on this last day of school here, I'm recording 3 parts in my 3 different classes because otherwise it would be way too long for one class. This way you'll have some time to work at the end of the hour. And this is part 2. All right, interval notation. If I were to tell you that this doesn't work in my function, and this also doesn't work in my function, but everything else does, how would you write that in interval notation? Try it. Pretty simple if you know what I'm talking about. You got to be experts at interval notation because it's going to be all over the place in the answers. You would say negative infinity to 0, parentheses. What comes next? Union 0 to 2, union 2 to infinity. Under what circumstances would you ever use a bracket? If it actually worked in the answer. So if this was a filled in dot there, then I probably would just never have even mentioned 2. I would have just said from 0 to infinity. You know what I'm saying? All right, but if it hadn't worked in here, for instance, say that's my new question, I'd erase this part. I'd put union. It doesn't work at all between these two. Then I'd say, what change would I need to make now? Bracket on the 2. All right, good. So there's interval notation. This is writing something in interval notation. I'm bringing it up because it's, if you don't get this, you're going to get like 8 answers wrong on the final because you got to understand how to read those. Okay. Any questions about it? All right. And I'm thinking you're comfortable on that. This, I actually already taught how to do this last the last hour, so part 1 of this series. So if you need to know how to find the equation from 2 points, go watch that video. Okay? It has a formula. It's really important. You should memorize. Y minus y sub 1 equals m times x minus x sub 1. Remember that one? I cover how to do that. I also cover how to do quadratic, which is finding the equation from 2 points when it's a quadratic. They got to give you the vertex and one other point. And I show how to do that on that video also. The general form for that one is y equals a times x minus h squared plus k. And if you're like, what the heck are you talking about? Then you better go watch the other video. Just giving you a reason you may want to watch that. Okay. End behavior from lead coefficients and multiplicities. Something I looked over the final and thought, okay, this is something I really need to know. This is going to come up. Boing, cut through. The fact that it ends going up tells me something important about the answer. It's a multiple choice test, right? So if it's there as an A, B, C, and a D, what do I know I got to look for? A positive one. The very lead coefficient of it. Let's say somebody thinks that this might be the right answer. What are 2 things wrong with this answer? One, it's not positive. We just talked about that. It should be positive because it's going up on the right. So this should be positive. What else is wrong with this? Yes, sir. In the back. The y-intercept's wrong. Y-intercept should be negative, right? So that is another reason that couldn't be the right answer. So I move on to another multiple choice answer, and it starts positive. Now, could that possibly be the right answer? Well, it leads with a positive. That's good. It's got a negative y-intercept. That's good. Anything else that might make you think, I don't know if that's the right one or not? What do you think? Yeah, it's got a degree 5. Does that mean this is for sure not the right answer, though? No, it doesn't necessarily mean that. Because, see, this is a bounce. That's 2. That's 3. So why can't I just say, no, it's got to be degree 3? Because there might be what kind of roots? Imaginaries. There could be 2 imaginary roots, and therefore it could be degree 5. So this would be an okay answer, and yeah, you choose that one. All right, multiplicities are when you're bouncing at a spot, like let's say here. Oh, that was pretty bad. I'm going to try that again. Boing. Cutting through, and that's at negative 3, let's say. Then I'd have y equals x, it's not an x, x plus 3 squared, and then let's say this hits over here at like 7. So then I'd say x minus 7. Now, what is a multiplicity? That's got a multiplicity of what? 2. And that's got a multiplicity of what? 1. The other kind that don't have up there is this kind, the snake. What's that worth? 3. Those are multiplicities. All right. Oh, wait. Oh, when it's in factored form. Wait. All right. What's the total degree of this puppy? Degree 5. And I don't have to say or more because it's not a picture. On a picture, you don't know if there's a measures or not. Here, I know it's degree 5, period. All right, what are its roots? 4 and 5, because those are the things that make it 0. Roots and zeros are the same thing. A lot of people goof this up and think there's a root at 7. Is that a root at all in the front? No, it's not. All right, so this is a double root here. This is a triple root there, making a total of degree 5. All right, if I was going to graph it, could this possibly hits at 4 and hits at 5, bounces at 4, snakes through at 5? Could that possibly be a right answer for it? Yep. Because it's snaking at the one spot, bouncing at the other spot. All right. That's in factored form. What if it's not in factored form? Well, then you factor it, if you can. Remember how to factor big nasty stuff? I think we talked about that a couple days ago. Do you remember the divide and conquer kind of way of factoring? Factor to the left, factor to the right, put them together. I want to give you one like that right now. See if you can handle this. 3x to the third plus 6x squared plus x plus 2. Try to factor that for me. Use the divide and conquer. Split it down the middle. Some people called it factor by grouping last year. However you want to say it, you should be able to factor this thing. If you haven't picked up your pencil, it makes me nervous. Now utilize it. Get paper, utilize the paper. All right, do you see that 3x squared can come out of this thing? And then what do I have left? X plus 2, right? Okay, I can double check that. This times this makes 3x to the third. That times that makes 6x squared. Yep, worked. And then I can factor out, well, nothing factors out, but then something always can factor out. 1. 1 comes out of that, x plus 2. Now, these guys are in common, so they come to the very front. And then what's left over afterwards is, when you're doing this, you're really dividing by x plus 2. And then there's 1 here, and 1 here, so they can all cancel. Final answer is that stuff goes in here. 3x squared plus 1. There we go, it's factored. Any questions on that? Okay, next topic. Write the area something as a function of x, or the perimeter of something as a function of x. So for instance, let's say I tell you it's a rectangle. I'm going to keep my llamas in there. And I know the area of this thing is supposed to be, according to the official website on llamas, needs to be about 400 square feet for him to be able to graze and move around enough. Okay, so what would the sides be? Write it down if you think you know. If the area is 400, how would I represent the sides? Some of you are drifting. Come back to me. We have llamas and brownies if you're in my hour. Okay. If you have a total of 400 for an area, you don't know how long the side is, you just call it x. The first side's easy. The other side's going to be what? 400. Is it over x or minus x? Over x. Because when I multiply them together, the area must be 400. And x times 400 over x. See, the x's cancel. The answer's 400. Yay. Okay. Now, I'll give you the other kind. Let's say I read... No, let's say instead of reading on the website, I say, all right, my llama better fit inside this because I've only got 500 feet of fencing. So this better work. What are my sides now? 500 feet of fencing. Pencil. Right. If it's 500 feet total, then this, okay, I can still start with x. Easiest side to name, right? And the other side must be, well, if I put 500 minus x, it's a really common answer, and I add up all the sides, do you get how it'll add up to more than 500? So what should it be? 250. Then, if you were asked to do a complicated word problem from this, all right, so I've got my 500 feet of fencing. And I want the area, what did I say before? Area to be 400. Set up the equation for it. I got 500 feet of fencing, and I want the area to be 400. All right, once you realize that I just asked you to do an area formula, you write the general form of the formula. Then you go and change the number and area. I know. Oh, you just told me that 400. And length was we're going to call the length the long one, which really is x. It doesn't really matter though if you put x here and 250 minus x there, or the other way around. But then how do I tell where those two cross? Oh, I just said it. You're going to have a graphing calculator for this thing, right? Graph both sides, see where they cross. I'd like you to take a second to do that. It's a pretty easy one. And hit pause, you grab your calculator and try it out. Graph y equals 400 on the one side. And graph y equals all that stuff on the other side. See where they cross. Okay. Well, I know the one's a parabola and the other one is it looks like it's touching, but man, mine looks pretty bad. How can I get it so I can see it better? Probably the zoom. Maybe I should try zoom 6 just to see if a standard zoom is going to work for this. And if I just think about it, one of my lines is at 400. Standard zoom is not going to work. So I'm going to have to go to the window. If you ever see the little blinky things on the side there and it just keeps going and going and going? If you ever have that happen, you want it to make it stop, just hit the on button. It breaks the cycle and it stops it from thinking. Okay, so I'm going to go back to y equals, no, I'm going to go back to my window and I'm going to put in some logical numbers. Can I have x be negative? No, so I might as well start with 0. And my maximum x, well, let me think. If my, the biggest, I have 500 feet of fence, so the biggest I suppose it could possibly be is 500. It's probably too big, but that's okay. Then I'm going to go down to y minimum. Y is my, y equals 400, so I need to be in the 500 or 400 zone. So I'm going to be a little less than 400. I'm going to go like from 300 to like 600 or something. Or maybe 500. That'll make 400 right in the middle of it. And now I'm going to hit graph. And I'm going to hope that that shows me a line and another line touching it. Ah, there's only one place that it touches. Is that possible? Yeah, that's possible. Sometimes there's two. Maybe one of mine's negative, and then it would be irrelevant anyways. Okay, so I'm going to do second. Calculate the intersection of the two spots, which is number 5. And then first curve, well, it's on it. I hit enter. Second curve, I can't tell if it's on it or not. And this is kind of a pain in the neck, but I'm going to assume that it's on it, because that's what the computer defaults to do, is it puts it on the first line and then it automatically puts it on the other line. Since I only have 2 lines, I'm gonna hit enter, assume it was right. Now the guess part, that means that I should probably get close to where I think it is. And if I arrow this thing around, it's telling, I'd love it if I could see the little spidery thing, but I can't see it, so I gotta be thinking. Alright, well, where should this be crossing? Well, it's definitely crossing at where y is 400. So I gotta move it until my y gets somewhere close to 400. And it's only getting bigger. Now I gotta go back this way. Get down to where y is around 400. I should start, oh, I missed it again. Dang. Y is 0. Y is, holy smokes, the numbers are huge. Alright, I'm just going to hit enter. Oh, there, it showed up right there. So, x is 248, y is 400. X is 248 is the thing I wanted. Yay, I just figured out that this side has to be 248. And then I can figure out how long the other side must be, which is 2. And 248, if this is really 2, oh, it's 250 minus 2. 250 minus 2 would be 248 again. Oh, you're right. X is 248. Sorry. 248. So this other side must be 2. All right, total. When you put that 250 minus 248 is 2. Okay, so then I take this times this, and that's supposed to have an area of 400. Did that work? Do you get how it's supposed to have an area of 400?
Well, yeah, but 250 plus 250 is about.
So, bottom line is it doesn't, this adds up to 500 on the 2 sides, so it's a total of 1,000. It didn't work. Is it possible you could have an answer that has no solutions? Maybe you can't take 500 feet of fence and make it have an area of 400. Maybe it's impossible. Okay, thankfully I got saved by the smart kid in the back row. Tell me the numbers again. I rounded them, and that was not smart. I rounded too much. You said this was really 248 point what? 0.4? About, okay, and then the other one is then, therefore, about 1 point what? Ah, look at all of a sudden how that, now it's going to shrink it down. So when I take 248 times 1.6, are you telling me that's about 400? Ah. All right. So I thought we were going to have an answer that it didn't work. But he caught me. Rounding, even just a little rounding mistake like that could make it completely work. And it does. All right. I had totally made up this question on the fly, and I kind of thought it might not work. That's why I kind of defaulted to, oh, it doesn't work. Because you can't just give you a random amount of fence in a random area and have it always work. But thank you for catching that. So kids will be less confused at home. All right, so bottom line is, once you got your formula here, graph this side, graph that side, see where they cross. It was a little bit of a pain to figure out where they crossed, but, and it looks like the decimal sometimes makes a big difference. All right, so there's my 2 dimensions, 248.6 by 1.6. Now let's talk practically speaking. Does that make any sense for a llama pen? 250 feet long by 1.6 feet wide. Your llamas ain't gonna be very happy. Because it's long, skinny little thing. It's got the right area, but couldn't we have just made it a giant rectangle and the llamas be happier? Yeah, we just have bigger area then. Know what I mean? And that's okay if it has bigger area than 400. Because I don't think the llamas have to have exactly 400 square feet. They just want at least that much. Okay, moving on. Rules to be a polynomial. There could be a question like this. That skipped a few terms. Is it still a polynomial? Yes, it is. So what would make something not be a polynomial? Do you remember anything that you could do to like makes it not work. Negative exponents, very good. If you throw in like that, not a polynomial anymore. Fractions where? Any fraction anywhere? No, I could have 3 over 2 right here. That 3 over 2 wouldn't make it not a polynomial. Yeah, you can't have fractional exponents. Okay? So if I have 5/3 or something, not okay. No fraction exponents, no negative exponents. And stay away from those and you'll be a polynomial. Okay. Exponential growth and decay. We haven't talked much about that this year. I'm going to refer you to the back of your book, or in your textbook. I know many of you don't have it with you, but in the very back of your textbook, do you remember if you open that up, there's a list of, here, I'll show you one in class. Here's textbook. Open to the back page. See the 12 graphs that are there? You were expected to remember those graphs. Okay, so let's go over a few of those. One of them is exponential. Do you remember how it kind of looks or not? If you don't, maybe you should make some notes on this. Yep, it's going like that. That's exponential. Do you remember the other one that kind of went with it, that was a reflection across this line right here, and therefore was its inverse? The log, very good. The log one looks like that. And it's y equals ln of x. Okay, this one was y equals e to the x. Those are a couple of those 12. Remember any more? I'm not going to go over all 12. You can look in the back of the textbook, but 1 over x is one of them. Yep. Remember what the parent is for the 1 over x, the rational function? It's got a dot here and a dot here, and then it gets closer and closer, never touches. Closer and closer, never touches. Remember that one? That's the 1 over x. Any others you know? Yep, y equals x. That's the identity function. Just a line goes like that. I missed the origin. It's the only important spot. Anyway, there's more if you want to look it up. Back of the book. That's another smart thing right before the test. Maybe you can take a little quick peruse of those. All right. Logistic, that's another one of those from the back of the book. All right, so I think that is all I'm going to talk about in your class. So again, I talked about a lot of things in the class before yours. You can go watch the video on that if you want to. I'm going to talk about more in the next class, mostly more word problems kinds that you can watch how to do. So that's it for the video.